Hello class, welcome to Algebra Lesson 4.1, which is all about solving systems of equations by graphing. By the end of this lesson, you should be able to use graphs to find approximate solutions to systems of equations. So first of all, you might be asking, what is a systems of equations? So in the last couple of chapters, we've talked about equations and functions, and we have practiced graphing in particular, and writing equations for those graphs. So what a system is it's just taking it one step further, and instead of just looking at one line at a time, we're talking about two. And the solution to systems of equations is where those two lines intersect. So in this picture here, you can see that this blue line and this red line intersect at -1, 3. So the solution to this question, what is the solution to these two lines? You would write -1, 3. You're just telling me where these two lines intersect. Okay, so that's the key thing that you need to remember for this entire chapter. That is what we are always solving for. Today, you're going to practice with the visual aid of graphs. You're going to practice graphing lines and seeing where do they intersect, and wherever they intersect, that is my answer. Then, as we move forward in chapter 4, we're going to stop graphing so much and figure out how to just manipulate equations to solve for this ordered pair. Okay, but like I said, today we're going to focus on graphing. So example 1, solve a system of equations by graphing. So let's quickly remember, this is if we have y equals 1/2 x minus 2 and y equals 3x minus 7. This is in my nice form, slope-intercept form, which is kind of nice to graph. So the way that I graph it is I'm going to use purple for this top equation here, and I'm going to start by plotting a point at my y-intercept, which is -2. So I'm going to go down 1, 2, put a point, and then my slope is 1/2. Remember, it's rise over run. So it's a +1, so I'm going to rise 1. Then it's a +2, so that means I'm going to run to the right 2. Rise 1, run 2, rise 1, run 2. And just because I'm recording this at home and it's not as easy to draw a straight line, I'm just going to try to give myself as many points as possible to do the best job that I can to get this to graph nicely for you. I'm getting off a little bit. Okay, so there's my first equation. Then I'm going to change pen colors just to make it a little easier. And I have this like reddish orange color. I have y equals 3x minus 7. So again, I'm going to start by plotting my y-intercept, which is -7. So I'm going to go down 7, plot my first point, and then my slope is a +3. Remember, this is a 3 over a 1. So I'm going to go up 3, because rise over run 1. Up 3, run 1. Up 3, run 1. Up 3, 1, 3, 1. Then it goes off my graph, 3, 1. Okay, so let's see how I can do, or how I do with trying to draw this line. Okay, not great, but not terrible. So what I want you to focus on is, remember, we're talking about a systems of equations. So I have graphed my two lines, and now I'm not quite done because I still have to list what the ordered pair is. So I can see these two graphs cross at this point, and this point would be ordered pair 2, -1. So my solution would be the two lines that I just graphed and this point, okay? So a lot of people remember, okay, I have to graph my two lines, and they sometimes forget to write that point on their test. So make sure you are practicing, make sure you're paying attention, and you are writing down where those two lines intersect. All right, now here is the same type of problem, except I want you to take time to graph it and see what ordered pair you get. Good luck. Okay, hopefully for this problem, you got a graph that matches mine, and then you got the ordered pair -4, 2. If you did not get that, please be sure to reach out for some help, whether that's from a friend or from myself. I am always more than happy to help you. Just let me know that you need some help. All right, let's move on to our next type of problem, which is infinitely many solutions or no solutions. So previously, when we practiced things with our equations, our inequalities, our absolute value, we talked about having infinitely many solutions or having no solutions. So the way that this works with graphs and systems of equations is if you have two lines that never touch, that's called no solution. And that's no solution because, remember, the solution to a system of equations is the ordered pair where they cross. And if you have two parallel lines, that means they're never going to cross. And that means there's no solution. Now, on the flip side, infinitely many solutions means that those two lines are touching in more than one place, right? And infinity means on and on forever and ever. So that means that the lines are always touching, or it just looks like one line on the graph. So we're going to start by looking at the graphs for these two equations. We have 15x plus 5y equals 25, and we have y equals 5 minus 3x. So remember, graphing from standard form here, you can either convert it to slope-intercept form. I know that's some of your guys' comfort zones. Or, remember, you've solved for the x and y intercepts. So you'd say 15x equals 25, so x equals whatever 25 divided by 15 is. And then to get the y-intercept, you do 5y equals 25, or y equals 5, okay? So that's just a quick refresher there. If you still have questions about that, reach out for some help, but that's not going away. So make sure you understand that. Okay, so if we graph these two lines, this is what we get. 15x plus 5y equals 25, and 5 minus 3, y equals 5 minus 3x. They have the same y-intercept. They have the same slope. And that means that the graphs are the same line. And this is called infinitely many solutions. So if I were to continue and get rid of the rest of that screen shade, you can see if I put both of those on one graph, this is what it would look like. It would just be one line because it's the same line, just written a couple of different ways. So whenever this happens, you would write infinitely many solutions. So infinitely many solutions. Oh, I'm getting a little special with my pen there. Let me undo. Infinitely many solutions. All right, so whenever you have two equations that end up being the same line, that's called infinitely many solutions. Now let's talk about the opposite of that no solution situation. So I have y minus 2x equals 6, and negative 4x, plus 2y equals 8. So the red line is my y minus 2x equals 6. The blue line is negative 4x plus 2y equals 8. And you can see that those two lines are never going to touch. Therefore, this problem, you would just write no solution. And you would be done. Okay? So when you graph and you get two lines that are parallel, that's a no solution situation. All right. Now I want you to look at this problem on your own and determine if this problem has infinitely many solutions or no solution. Good luck. All right, let's look at example 3, write a system of equations. Monisha and Holly have 14 more days to finish reading the same novel for class. Monisha plans to read 9 pages each day. Okay, so Monisha is going to read 9 pages each day, while Holly plans to read 20 pages. Oops, that should say read, not ready. My apologies. Plans to read 20 pages each day. Assuming Holly and Monisha both maintain their reading plan, when will Holly catch up with Monisha, and who will finish reading the novel first? So the first step that you would have in this problem is to come up, with an equation for each of them. So Monisha plans to read 9 pages each day. So Y is going to be how many pages she has read. And then she's going to do 9 pages each day. I don't know how many days she's going to read yet. Plus, and then Monisha's starting value is 96. Then what I'm going to do is I'm going to do the same thing for Holly. I'm going to figure out the equation for Holly. So her total number of pages equals, she's reading 20 pages each day. I don't know how many days, so I'm going to use X. Plus, she's already at page 6. Okay, so those are my 2 equations. Then what I would do is I would take those 2 equations and graph them. So I've already done that just to save a little bit of time in the video. And you'll see that this blue line actually is Holly. And the reason I know that is my y-intercept for Holly is 6, which is pretty close to that 0. My y value for Monisha is 96, so that's obviously going to be a little higher. So Holly's the blue line, Monisha is the red line. So then we want to figure out when will Holly catch up with Monisha. So if we look, they intersect at about the point 8.182 and 169.636. So I'm going to just round. This is a little more than 8 days. So in order for her to catch up, she's going to have to read for more than 8 days. So I'm just going to say 9 days. So Holly will catch up after 9 days. Oops, it would help if I wrote days. And then who will finish reading the novel first? So you can see that Holly's line kind of gets higher. It passes up Monisha's. So Holly will be the first person to finish her novel. Okay. If you have questions about that, please don't hesitate to ask. I'm more than happy to help you. One thing I will say is when you're graphing, more often than not, I'm going to give you problems that work out nicely, but you will sometimes get problems that look like this, where you have these decimals, which are really gross. And so in the future lessons in Chapter 4, we're going to talk about better ways to solve these when they don't work out nicely. So when you're going to have those decimal answers, there are better ways to solve it than trying to graph it and see where do they intersect. So we'll cover those in future lessons, but for now, use what you know, which is graphing. And here is a nice little concept summary to help you keep track of system of linear equations that have one solution. Is when 2 lines just cross at one spot, that's the one solution. If 2 lines overlap, that is called infinitely many solutions, and it looks like there's just one line on the graph. Then if you have 2 lines that never touch, that's called no solution because they never intersect. So you don't have that solution. You don't have that point. If you have questions about anything from this lesson, please don't hesitate to reach out and ask for some help. I am more than happy to help you. Have a great day.